Alright, our final lesson for this week that we missed. Lesson 88, the distance formula in the relationship PV equals nRT. Now, in the past, we found the distance between one point to another point by using the Pythagorean theorem. What we did was we plotted the points, we counted this side right here. This is the change of x, how x is changed from point to point, which we figured out to be 6. And then we would count using little boxes the distance from here to here, which is actually the change in our y direction. And then we would do the Pythagorean theorem. We would say 6 squared plus 7 squared equals c squared. And we would find the distance between those points would be 190 or 85, square root of 85. And that is how we did the distance problems in the past. Well, we're going to learn a new way to do the distance formula where you don't have to plot the points. And I would assume you would always use this new method instead of counting the points. Because what if the points were so far away, like 100, and you don't have that many spots on your graph, and then you have to count the change in y and change in x, and it would just take you forever. So we have a formula to determine that. And you can see here that the way that we got the 6 is we saw how much the x changed from this point to this point. And we can rewrite that as how much x changed from point to point as x2 minus x1 quantity squared. Whenever we're doing change, they typically do the second point to the first point, just like in the slope formula. So we got the 6 by, if we found how x changed at this point, let me just write that in. This point is 1, 2. This is negative 2, 1, 2, 3. And this point down here is 1, 2, 3, 4. And 1, 2, 3, 4. It's 4, 4. Now if we're going to see how the x changes, we would do 4 minus a minus 2 squared. And you can see that would be 6 squared. Then if we did our y's, it's the same thing. This would be y2 minus y1. So if we do this one again, the y's would be, y2 would be 4, minus, whoops, this should have been a negative y value, minus a minus 4 squared. We're going to get exactly what we got up here. We're going to get 6 squared plus 7 squared equals c squared. And if we just want c, we would just take the square root of both sides, and we would get the same thing that we got up here. Now this is actually the formula to find the distance. Its distance equals the change in x squared plus the change in y squared, the square root of it all. So instead of plotting our points and counting, we're going to put everything into this distance formula right here. It's how the x changed squared plus how the y changed squared, and then the square root of it. This is another one of those formulas that you need to memorize along with the distance formula. So let's just try a couple examples, one example actually, with the distance formula. I'm going to rewrite the distance formula since I just got rid of it. Its distance equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then it's the square root. So you can see that's just the Pythagorean theorem with the change of the x direction, change of the y direction. So again, just like we did for the slope problems, this would be x1, y1. This would be x2, y2. And we'd simply plug it into the formula. So our x2 would be negative 5 minus 4 quantity squared, plus y2 is 3, minus a minus 2, be careful with those, squared, and then you take the square root of it. And we would get distance equals, this would be negative 9 squared plus 5 squared. And we get a final answer, 81 plus 25. Grab this right here. Square root of 81 plus 25. And the distance between those points is the square root of 106. Now, of course, you probably won't put in all the steps like I did, but I just wanted to show you how everything works. So, instead of counting the points, this is the distance formula. Really important formula when you use it over and over again, so you need to commit this to memory. Alright, let's move on to the second part of our lesson. This one's equally as easy. A little bit of chemistry, I guess you could say. This is the formula PV equals nRT. They'll give you this formula. You don't have to memorize that one. This is just for your information. P is pressure in atmosphere, V is volume in liters, N is the number of moles of gas, R is a constant, it's always 0.0821, but they'll give you that too, and T is the temperature. So, it's very simple. This is substitution. It says use the relationship PV equals nRT to find the number of moles and the amount of gas when the temperature is 273 Kelvin. The pressure is 1 atmosphere and the volume is 8 liters. So we want to find, they're asking us to find N. So we take our formula, nRT, we solve it for N. N equals PV over RT. When you're in physics and chemistry, a lot of the work that you do is just solving for the variable that you're looking for. That's why you need to know your algebra so well for those subjects. Then you just substitute in all your values. P for pressure is 1. V for volume is 8. All over the constant 0.0821 times T for temperature, 273. And you just plug all that in your calculator and you get an answer. 0.357. And this is in moles. You'll learn about that in chemistry. That's all there is to these problems. We'll do another one real quick, but we probably don't even need another example. Use the formula PV equals nRT to find the volume. So this time we want to isolate V. So you would say V equals nRT divided by P, and then you just substitute in what they gave you. So N is let's see, where is N? N is 0.82832. R is constant, 0.0821. Temperature is 400. Divide that by our pressure, which is 3 atmospheres. And you just put that in your calculator, you get volume equals 9.11 liters. And that's all there is for lesson 8.